This is Enter the Java. This is our numbers method lab. And in this lab, we are supposed to go through a list of methods to show how we understand how different functions are used using numbers and calculations. So the first thing that we're going to do is open Netbeans. Okay, and our project should be open already. Okay, so the first thing that I did in my project was start out with the different data types. The first data type are integers, and this is for storing integer values between the numbers -2 to the 31st power and anything beyond 2 to the 31st. So it's I think it's but it's a large number, two large and small numbers. So it can't just be any number by like the millions or the billions. It has to be certain integers of certain values. And then the second data type is a float. So for the first one, it was A was 56, and that's what an integer would look like, a basic one with 2 digits. And so a float would have a decimal number, so it's used for storing decimal values. And anytime you use a float in your Java program, you have to put the letter F behind it. You can't just use a decimal. So say if I remove the F, there's going to be like an error sign and it won't read it. So see here, if you're ever using a float value or variable in your program and you put in the value right after the variable, just know that you're missing the letter F. The next data type is a character. It's shortened for CHAR, and it's for storing single value characters. For this one, I use the letter C instead of a number. So again, a character is like a letter between A through Z, and certain special characters. Okay, and the next data type is a Boolean, and this one is for specific data values that is true or false. So for the variable dog, I put true, and it could either be true or false, but again, this is a Boolean, so it can only be one of the two values, true or false. So the next data type is byte. For this variable, I used the letter E, and then that value is 127. So this one is an 8-bit data type with values between 127, a -127, and 127. It is smaller than an integer because, again, an integer is between -2 to the 31st power and +2 to the 31st power. So it's a lot smaller, 127 versus 2 to the 31st power. The next data type is a short. This one I use the F variable, and it's similar to an integer, but it's smaller. So instead of it being like 2 to the 31st power, it would be like 32,768, and it's negative between the numbers -32,000 and positive. The next data type is a long. The variable I used in this one is G. This one's a lot similar to an integer, but it's a lot larger. So instead of it being 2 to the 31st power, it's 2 to the 63rd. And this one is used for a lot larger numbers. And the next data type is a double. This one I use data flare, but a double is similar to a float but for longer decimal numbers. So for a float, if you're using a float, it would be helpful, like say you're doing a science project and you needed very specific numbers, like significant figures that are decimals that have like 2 or 3 digits after the decimal. It would help to use a double so you can use specific numbers, because again, in like science or medicine or in a lot of STEM majors, you might use large numbers that go far, like way past the decimal sign, and way smaller numbers, or very specific numbers, it would help you use a double instead of a float, because a float can only go is only so big. So for the next part was printing the data type. So we'll just run this, and then we'll select the main class. Okay, if we go to the top, it should show us all the different integers. I showed it so that it can print down different sections. So it would start out with, let me make this a little bit bigger. So it would start out with the data types, and then the integer variable is 56, the float variable is 98.7. So in the beginning we put that the variable b has a value of 98.7, and how I mentioned that you're supposed to put the f at the end, it won't show when you put one in the output. It won't show it. It's just so that the computer will know that it's a float versus a double. And it's the same thing with a double too. Like instead of putting just 99.987 and then just leaving without the d, it wouldn't work. You'd have to put the letter d right next to it. So it's the same thing, follow the same kind of rule, except it's with its own its own character. So you can't just put any letter. It would just be D for double and F for float. That's easy to remember, and it won't show it in the output. So it's going to show us the float variable at 98.7, the character variable is C, the Boolean variable is true, the byte variable is 127. It's a lot similar to what it was above, but because the only thing that helped me display my variable at the top was this list of system print lines, and then instead of like putting in double Boolean data flare, I just referenced the variable that I listed above. So I put system print line integer variable is plus a, and a has a value of 56, and then it's going to print out 56. The variable is a 56, and then so on and so forth. So the next thing that I did was to show the method of numbers, and so each and every method has its own method. So for the first one is value, and in this one it converts the value of a number. It converts the value of the number object that invokes the method to a primitive data type that is returned to the method. So in this one, you can use, I just use an integer and then the letter 12, and it would take that value and it would turn it into the whatever type of data type that you would want it to be. So for this one, it's an integer in the first variable. And say I want to turn it into a float. I would write out system print line x, which is the x variable, and I would put float value parentheses. And then when you see here below in like the x value section right here, the second one down, it shows 12.0. So now it's not an integer anymore, it's a float. And so for the next one, it's going to turn it into a byte value, and then it shows the same thing, 12, and then a short, and then a long, and then a double. So the only thing that you can really notice now is that compared to like the float and the double, you can see the decimal point after it, but you can't really notice it between like the long, the short, and the byte, because it doesn't really have anything after it, because it's just reprinting the same numbers. But I'm sure if you use like a different number, it would be more noticeable. So for the next method that I did was compare, and in this function it compares the number of object to the argument. So I use y, and then has a value of 23.34f, and it's a float. So it would take it would compare this value 23.34 to 3. And then if you look down here to the compared to section, it's a 1 difference. So it would use numbers between 0, 1, and -1. And if it's equal to, it would be a 0. If there's a greater difference, it would be a 1. And if it's a less than difference, it would be a -1. And because 3 is less than, because 23 is more than 3, then so the 1 is a positive. And when you compare 23.34 to 54.3, 23 is smaller than 54, so now the 1 is negative. And in the next method, I did equals, and in this one, the function determines whether this number is an object is equal to the argument. And the output would either be positive or, true or false. So for this variable, I used a byte data type with the variable z, and the value was 11. And to use this to, like this, the syntax would be to system out print line, the variable dot equals, and then like a number that you want to compare it to. And I used 54.3. I used a float. And so on this one, they're not equal, so it would put out false. And in the next, second example would be to compare the data type z to itself, and it will be true because it's the same number. Okay, and so then the next function is a value of, and in this one, it returns an integer object holding the value of a specified primitive. So in this one, it takes the value, the variable with the value of 2.78, and it compares it to another variable that you put it in self. So I use another variable called float. I use another data type float with the variable u, and it has a value of 80. And so if we go down to value of, and it just changes the float. It changes the w to so it prints out the w, and then it prints out the u. It prints out the value of it. So in system print line, I put out the first variable, so it should be 2.678, and when you look at the output, it prints out 2.678. So when you go back to the second line, when it says system out print line u, the u variable, it should print out 80, and it prints out 80. So the next method that I did was toString, and this one returns a string object representing the value of a specified integer. So for this one, we scroll a little bit down. So our first data type is an integer with the variable t with the value of 3. So this one, it would just print out the string or the integer that I have, and it would just print it out 3. But say I wanted to take 3 and I want to change it to a different value, and I want to change it to like a string or something. It doesn't even have to be like another, well, for this one it does. So say I want to change a 3 to a 9, it's going to print out 9 instead of 3 for that variable. So the next method that I did was Parseint, and in this one, it's used to get the primitive data type of a certain string. So I have 3 variables in this method. The first variable is an integer data type with the value of a 9 string. Well, so it's a string with 9 as its value. And the next one is a double, and it's 5, and then the integer 14.6. So this one would take each value and and just print it out as is. So say I want to multiply two numbers, 144 times 16, it will print it out. Like if I want to take a string 144 and multiply by 16, I would put one in the quotations and the second one as like an integer on its own. So for the first one, they would just put the s value and it would just print out 9, which is what it did. This is the first one, 9. And then the second one would be a double, so that's for the variable r, and it prints it out 5.0. And so the next one is 144 times 16, and then it just prints out 144. It prints out 324, which is what 124 is. Okay, and so the next method that I did was abs, and this one returns the absolute value of an argument. So in this one I have three variables with three different data types so that it can show what each data type would look like. So for this one I took into the integer p, variable p with the value of -50, the double O with a negative 100.98. They're just random numbers, and so in the bottom it would show me the absolute value of those numbers, and it should be just like 50, 100, and then 98. Yeah. So let's just type it out, and it would just be math.abs with the variable in quotations. And then let's run it again. So if we see here, the output is 50, 100, and then 98. So say if we put like 50, 100, like without the negative numbers, it would still tell me the same numbers. The whole point of this method is to show me the absolute value. Okay, so the next method that I did was seal. And in this one, it returns the smallest integer that is greater than or equal to the argument, and it's returned as a double. So in this one, I used two different variables. The first one is a double data type with the variable m with the 73.45 value. So when we looked at seal, the smallest integer that is greater than or equal to would be 74 for the m variable, and then for the float, 45.9 would be 46, and that's like the greatest one that it could be. So the next one is similar to seal but is floor. So this one is it would show me the largest integer instead of the smallest one. So in this one we had two variables, k with 12.34 and a float of 45.67. So like the largest number it would be like a 12 or a 45 without the decimal number. So like I think this is the whole point of this, is so that it can give you a number without the like the decimal point at the end. So it shows here floor 12 and then 45. And then the next one is RINT, R integer. So this one returns the integer that is closest in value to the argument. So in this one I have three of the same data types, and each integer, h has a 54.32 value, h has a 54, and then g has a 54.99. So in this one the output would be the closest number, and because these numbers are so similar to each other, the output would be all the same. So, well, mostly all the same. So the first two is both 54, because this one's 54.32 and this one's 54.00. And then because this one's so close to 59, it's going to be 55 instead of 54. So say I put 54.55, it would still be 55, because I think when you're rounding numbers, it goes, if it's 5 and 9, it's rounding up, and then 4 and below it's rounding down. So the next method that I did was round, and in this one it returns the closest long or integer as indicated by the method return type to the argument. So I use two different data types. The first one is a double with a variable f and a value of 63.5, and the second one is a variable e with a 52.2 value. And this is what the syntax should look like, and then the output would be 64 and 52. So that would be the closest numbers to the 63.5. Okay, and so the next one is min, which is like the minimum, and this one returns the smallest of the two arguments. So the syntax would be system out print line math min, and you would just put in, at least it makes sense to me to put in a list of numbers, and say you had like a long list of like data that you had from like a lab, and you wanted to know what the smallest integer was, or like the smallest decimal number, it would just give it out to you. And for this one, it's not a long list, but I can understand how this would be useful in like a larger scenario, or like a different scenario. But in this case, we have two numbers, 14 and 88. 14 should be the smallest number. I think we already know that. So the output would be 14. The max is self-explanatory, the same thing. It would give us the largest of the two arguments. So this one is two numbers, it's simple, and I use floats, 62.5 and 4.0, and we already know which one's longer, it's 62.5, and so the output would be 62.5. The next method is an exponent, and I use the same data type, two different variables, D with the 9.0 value, C and the 2.0 value, and in this one it returns the base of the argument logarithms e to the power of the argument. So it takes the value of e and it uses it as an exponent. So the whole point of using two different variables is that one of them is going to be the base and the second one is going to be the exponent. So in this case, 9 is the exponent and e is the base, and so the value would be 8103.084. It's a long number, and then they're all like math equations, so it's a long well, it's not that long. So system print line print f, because it's a float, and then you just have like a test, like a string. The value of e is %.4f %n, and then math.e. E stands for exponent. And so the next method that we did was log, and so in this one returns the base of the natural logarithms e to the power of the argument. It has a similar setup to exponent, but I'm sure the numbers will be a lot different because it's a different formula. So we'll just read out the output. The value of e is 2.7183. Log 7.000 is 1.946. This is another similar one, and this one uses the power. This returns the value of the first argument raised to the power of the second argument. So the first argument would be 8, and the second argument is 4. So it takes 8 to the 4th power. Let's see, something. But it just takes two numbers and multiplies them by however many that is used or is said. So we'll just read the output, and in this one the value of e is 2.7183. I have the same, they're all the same thing, so that I can have like a little bit of consistency. But I'm sure in like other scenarios, when you're using this in like a classroom or professional settings, the exponent will be different, the value of e will be a lot different. But just for consistency and just for examples, e is always going to be 2.183. So back to power of. The value of e is 2.7183 with the power of 8, and then 4. Again, these are like the variables that I put above, and then which is 96.000. The next method that I use is square root. This one's like self-explanatory. We already learned about this in like high school or middle school, and this one returns the square root of the argument. So we'll just I've put two different data types, two of the same data types with different variables. The first one, variable x with the value of 11.635, the second one, variable y with the 2.76 value, and so the output for that one would be, again, it's repetitive, the value of e 2.7183 square root 11.365 is 3.411. And so the next method, a lot of these are math related. Most of these are math related. But these ones are more like formulas that we learned in like calculus or trigonometry or something. So the next one is sin. I use the two of the same data types, doubles. This one's a degrees with the value of 45. And this one returns a sign of the specified value, of the specified double value. So I think in this one, for this method, the specified value has to always be a double for it to work, not a float, not an integer. I think for this one, for it to work, it has to always be a double. So for this one, I use a 45, which is the double in this case. And so the output for that one is the value of pi is 3.14. And then the sine of 45 degrees is 0.7071. So the next one is repetitive. It's again like the other one, but instead of giving us sine, it's going to give us cosine. So we're using the same degrees, 45 degrees, and the cosine of 45 degrees for this method is 7071. And the next one is another one, is tan. This one returns a tangent of a double value, and so the tangent of 45 degrees is 1. So like I said, it would always, because the input was a double, the output would be the double too. So it won't just put just 1 without the points 000, because again, in scientific scenarios, in professional setting, in classrooms, you will always need like the exact number. It doesn't matter how many numbers is past the decimal sign. The more specific the number is, the better. So 1.000 is for what it is in this case. And so the next one is the is going to give us arsenine, and this one is going to give us the specified double value. And so the value of ASIN is, the ASIN of 45 degrees is 0.7071. The next one is the same thing, arc cosine, and then the next one is 8 arc tangent. So it would be 7071, 7071, and then 7071. And so because for this one, tangent has two different methods. So for the first one, it's using in radians, and the setup is a lot different too. So if we compare the two, this one takes the arctangent of the specified double value, and atan2 converts the regular coordinates x, y to polar coordinates r, theta, and returns the theta. So for the output of atan2 of the arctangent, this one's going to be 0.98. Yeah, a long number. And so the next method is degrees. And so this one converts the argument to degrees. So in this one, we use the same data type, two different variables. The first one is 45, and the second one is 30. And the degrees of 45. Printing 45 in degrees is 2578 with 31. It's a long number. And then the degrees of 30 is 1718, and then a long number behind it. And then I'm not really paying attention to detail because, again, these are just examples. And then the next one, it's radians, and this one returns the argument to radians. I use the same data types, the same number, so double data types with x and y variables, 45 and 30. So the radians of 45 is 0.7853, and then etc., etc. And then the 30 in radians is 52.5235, etc., etc. And the last method, numbers method in Java is random, and this one is simple. It just returns a random number. And it doesn't have to be, it can be positive or negative. It can be a whole number or a decimal number. In this case, both of them were decimal numbers, but completely random. And this one is 0.94, etc., and then 0.84.